Hello. One of the questions that came up during our tutoring session was about the differences between the different types of perpendicular bisectors and about circumcenters. And those are all kind of connected, so I'm going to do a quick overview of the whole set of constructions that are related to perpendicular bisector. So first, perpendicular, perpendicular, it's when you have two lines that make a right angle. This line is perpendicular to that line, and you get four right angles. Bisector means it goes right through the midpoint. So although this is perpendicular to that given segment, it's not in the middle. So if I go right through the midpoint, then I'm perpendicular and I've bisected the original segment. That's what we want to create. Your basic strategy is you're going to draw a circle from both ends. And the only condition is it needs to be more than half. That's too small. That's too close to half. And that's too big because I'm going to miss my segment. So I just need something that fits on the segment. I could go the exact length, but I'm going to go somewhere between the middle and the full thing. And I'm going to draw a circle from this end. And I really don't need the whole circle, but I'm going to do it this time. And then I come to the other end of the segment and draw a circle that has the exact same size, exact same radius, so I don't change my compass. And what will happen is that because I made the compass setting more than half, the two circles overlap. And when they overlap, I create those 2 points, which is what I need. And if I connect those 2 points, I will have a line that is perpendicular, or a segment that's perpendicular to the original segment. So I've got four right angles, and then that's going to be the midpoint. So it's perpendicular and it's a bisector. I'm going to do it again over here on the small segment. Again, I just need something more than half. And circle, or at least the part of the circle that goes towards the center. I know my bisector is going to be somewhere in here, so I need at least that much of the circle. Let me make sure I didn't change the compass setting. I did. Let me get it lined back up. Okay, and then I do the same setting from over here. And again, I don't really need the whole circle. If you want to kind of lift it up, I just need that much of it. And where those intersect, I create 2 new points. And when I connect those, it's perpendicular, and I bisected the original segment. One more time. I can, here's what happens, by the way, if it's too small. If I don't have my compass setting large enough, then that circle and this circle, whoops, I messed up. But those two circles do not overlap. That's not going to help me. I need where they overlap to get those 2 points. If I get too close to the middle and I try to do these 2 circles, and it's okay that we overlap another problem. Oh, whoops, still too small. They did not overlap. So let me get a little bit bigger. Okay, bigger, they touch, but they touch like at 1 point. I need 2 points. I have to have them actually overlap. So it can't be less than half. It can't be right around half. It's got to be obviously more than half. So I'm going to do this one more time, and I know this is probably looking a little crazy because I have so many lines going on. But if I have a good setting, my 2 circles will overlap right here and right here, and I can connect them. again. I know I already said one more time, but we'll do it again. If I happen to make this the exact length of the segment, whoops, no big deal. Let my paper slide. Okay, if I make this the exact length of the segment, I'm not doing a good job today. Okay, it just means it's going to go through it's going to go just around the end point. No problem. I'm still looking for these 2 points. Now, obviously, that slid on me, and so this is really kind of inaccurate here, so I'm not even going to connect it. I'll do a dotted line. Something like that, because I would need to erase that and go back. But perpendicular bisector, you swing a circle from both endpoints. The circle has to be large enough to overlap in 2 parts, so that when they intersect, you get 2 points. Okay, here's the variation of that. I can use a perpendicular bisector to make a square. So I start with the circle, and where the center was, I drew a diameter through there, and when the diameter touches the circle in 2 points, those are the endpoints of that diameter. I'm going to do a perpendicular bisector. This time, knowing more than half is easy because I can still see where I poked a hole from the original circle. I know where the exact center is. But I still don't want to just be a little bit more than half because the intersection won't be easy to see. So definitely more than half. Again, you can go the full length, but just something obviously more than half. I'm going to go about right here. Again, I don't need the full circle. I'm aiming towards creating this segment, so I need the parts of the circle above and below that. Exact same setting. I kind of get an eyeball shape here in the center, and where those overlap, I got 2 points, and if I connect those 2 points, I want to make sure I extend that, so not just connecting these 2 points, but I want to touch the circle to create this point, or those 2 points. So I have A and B, which came from where the original diameter crossed the circle. C and D are the points I used to make the perpendicular bisector. E and F are the points I use for the rest of my square. So if I do those 4 points on the circle, I am going to get a perfect square, or as perfect as I can. And there's a square. I just did the perpendicular bisector. A variation of this, just so you know what it looks like. What if I had made this really big? I'm going to go bigger than the segment even. Uh-oh, that'll go off the paper. So that wouldn't be a good idea. I'm going to come a little bit smaller, so my radius is bigger than that whole diameter. And let's see, I want to make sure I fit on the bottom of the paper. So I need here and here. So I didn't do the whole circle, but I did enough of the circle. I'm going to do the same thing from here. And my ruler's probably not long enough. But where those intersect and where those intersect, if I connect those, I can see that that's going to line up with the line I already made, which makes sense because there's only one perpendicular bisector. So even if this is longer, I'm still going to get that same segment inside the circle, and my square will be the same. Doesn't matter if your 2 circles intersect inside the original circle or outside the circle, same thing. But one way to get a square is to do a perpendicular bisector to the diameter of a circle. Okay, circumcenter. This was actually one of the big questions. A circumcenter is a point where the three perpendicular bisectors, where those intersect, that point is called the circumcenter. So let's put some letters here to make it easy to talk about. Segment AB, perpendicular bisector. I need this set for obviously more than half. I'm going to do a circle from both ends, and I hope those pencil lines are dark enough for you to see. Create the 2 points where my 2 circles overlap and connect them. And I have a perpendicular bisector to segment AB. Then I'm going to do the same thing to segment CB. Make sure that this is set for obviously more than half. And it's going to get a little messy because lines are going to be on top of other lines, but that's okay. So I draw enough of the circle. I do it again from this end, and I kind of pay attention so I know which part is for the current construction versus this one over here. But I get my 2 points of intersection, connect them, and now I have a perpendicular bisector for segment CB. Then I'm going to do segment CA. Some people will be more comfortable turning it so the line's kind of horizontal, because that's like the first one I showed you. I don't have to turn it though. I can do it from this side, or this perspective. Make sure it's set for obviously more than half. And I draw enough of the circle. I come to this end and draw enough of the circle. Find my 2 points of intersection, and I am going to connect them. And if all things go well, those 3 perpendicular bisectors will intersect in 1 point. This point right here. That point is your circumcenter. Now this is sort of unique because the triangle I happened to start with was obtuse, and that forced the point out here. Most of your triangles, well, depending on how you draw them, but chances are it'll actually end up inside the triangle. So it doesn't matter if it's inside, doesn't matter if it's outside. It could actually even fall right on the circle or on the triangle. But the point where those 3 meet is called the circumcenter. I'm going to do another triangle. Call this circumcenter continued. So let me do something that is not obtuse. Okay, and that triangle has 3 acute angles. I'm going to do a perpendicular bisector to each side. Again, radius set for more than half. Draw a circle from one end, part of a circle. Draw the circle or part of a circle from another end. And oh, you can see they don't intersect here. No big deal. I just didn't draw enough of the circle. Make that a little bit bigger. Find your 2 points of intersection and connect. Do it to the next side. I'm going to come over here, make sure that's more than half. And you know what? I'm not even going to change my setting. I'm just going to, because that's still more than half, I'm going to extend that. And I'm going to come over here. Find my 2 points of intersection right here where my 2 circles intersect. Connect those. Remember, the only thing we ever use the straight edge for is connecting the dots. And then one more perpendicular bisector. And just for efficiency's sake, I'm going to use the same radius setting again. It's obviously more than half. I kind of like it because all three of them end up like part of the same circle. And like this circle was extended, so I get a few less lines. Okay, I did that side, and I'm going to do this side, so it's matching up with previous circles because I used the exact same radius. My 2 points of intersection, okay, this one, and I'm going to connect. And if all goes well, you get exactly 1 point of intersection for all three of those. So circumcenter is where the three perpendicular bisectors intersect. That's how you make it. That's the part you need to know. Little bonus fact, what does it even mean? Well, circ, like a circle, like circulate, has to do with going around. To circulate something, hey, well, I need you to circulate this petition. Well, you're going to pass it around. If you were a sailor and you were going to circumnavigate a continent, to circumnavigate a continent, you would have to sail around it. So circ has to do with go around. So circumcenter is the center of the circle that goes around. So this is bonus again, but I'm going to set this radius so it goes from my circumcenter to the vertex of the triangle, and that should match. Oh, it looks like I'm off a little bit. Let me adjust. That setting should match that setting, should match that setting. Okay, who cares? Well, you don't really need to care because you don't have to do this, but this is just the meaning of the word. If I circumcenter, if I use that point as a center and I draw this circle going around, whoops, let me adjust that again. Well, I can see I'm off a little bit because I didn't hit both of those exactly. But close. I'm going to make this dotted just to make it pop a little bit more. This is a circle that fits exactly around this triangle so that the vertex of each triangle is on a circle. When that happens, we say that the circle is oops, let me spell that right. Circumscribed. Scribe has to do with writing, like an inscription, or old school back in the day, the people who hand copied manuscripts were called scribes. So circumscribed means essentially written around. So that circle is written around that triangle such that each vertex touches. So circumcenter is the center of the circle that circumscribes the triangle we started with. Way more than you need to know. But if you need to find a circumcenter, do your three perpendicular bisectors, and that is the point. Next, oops, that's back to the original. Again, three perpendicular bisectors. That point's the circumcenter. Let me go ahead and make that same point on this one. By same point, I don't mean a dot, but the information. If I drew a circle here, it would touch all three corners, all three vertices of that triangle. Bonus information. Okay, next, bisecting an angle. Sounds totally different. It's an angle, it's not a segment, but you're going to do the same steps. You're going to pretend that, you're going to pretend you're doing a perpendicular bisector. So first thing I'm going to do is just swing a small arc from the vertex. I need to do that to create my two starting points. and I'm going to call that W and X. And I need W and X because they are the same distance away from the vertex. If they happen to give me points here, like D and F, no good. They're not the same distance away. So if they gave them to me, fine, but I can't necessarily use them. I need to create 2 points that are the same distance from the vertex, and I know they're the same distance because we use the same radius to draw them both. Now, here's where you're going to pretend. Pretend there's a segment going from W to X. You don't need that segment. Don't draw that segment, but pretend there's a segment there. What would you do to make a perpendicular bisector? Well, what have we been doing? Draw a circle from both ends. I'm going to make this obviously more than half. And where the two circles intersect, I create 2 points, connect the dots, and I can keep going here, but I'm mostly interested in this part. And I did not line that up exactly. Do a little bit better. But that should go right through the vertex, and it makes this side congruent to this side. We have bisected that original angle. How do I bisect an angle? Swing an arc from the vertex to get these 2 points. Pretend those 2 points are the endpoints of a segment. Do your perpendicular bisector.